Hello, in this video I'll be going over the review number 2 answers. Let's begin with number 1. It states the following: how many ways can 5 different television programs be selected from 12 programs? The key word is selected. Whenever there's a straight selection without regard to order, we're thinking combinations. So it is 12C5, which is 792. Number 2, how many ways can 7 students be seated in 7 seats? We're thinking arrangements. It's a permutation. We're using all the objects. 7 factorial, 5040. Number 3, how many different license plate numbers are possible if repeating non-zero digits are used for the 4 leading characters and non-repeating letters are used for the 3 trailing characters? Well, the first 4 positions are repeating non-zero digits. Remember, there's 10 digits to choose from. Since we're working with non-zero digits, we have 9 choices. And since the items are repeating, it's 9 times 9 times 9 times 9. We're using our fundamental counting rule here. For the 3 trailing characters, they're non-repeating letters. There's 26 letters in total. We pick 1 to be in this position, so there's 25 choices for the next position, followed by 24 for the last position. Multiply these out to get 102,351,600 different license plates that are possible under those conditions. Number 4 says the following: you have 5 places left for stamps in your stamp book, and you have 8 stamps. How many different ways can you arrange? Remember, arrange means permutation, the 5. So we're thinking permutations. We have 8 stamps to choose from. We're choosing 5, so it's 8P5, which is 6,720. Number 5 says, when 2 dice are rolled, find the probability of getting, part A, a sum that is greater than or equal to 9. So we can use the sample space to help us. So a sum that's greater than or equal to 9, that means 9, 10, 11, 12. Well, if we count up all the pairs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 pairs that match this condition. So 10 out of 36, remember there's 36 possibilities in total for tossing 2 dice. 10 out of 36 reduces to 5 out of 18. Probability of getting a sum of 7. Here's a sum of 7. There's 6 different outcomes that give a sum of 7. So 6 out of 36, 1/6. And then a sum of 5 or 6. 5 is 1, 2, 3, 4. 6 is 1, 2, 3, 4, 5. So 5 plus 4, 9 possibilities out of 36, reduces to 1/4. Number 6 says a card is drawn from a deck. Find these probabilities. Getting a 7 in the club. Going back to the sample space for a deck of cards, we have the clubs. A 7 in the clubs has to have both properties. So there's only one card that's a 7 and a club. So it's 1 out of 52. Now a 7 or a club, or means we add. So we're adding all the 7s with all the clubs, but remember, we never double count. So let's do that. So there's 4 7s. We count all the clubs except the 7 of clubs because we've already counted it with the 4 7s. So it's 7 plus 12. It's 4 plus 12, which is 16 out of 52 cards, reduces to 4 out of 13. A red jack, well, there's 4 jacks, 2 are black, 2 are red, so 2 out of 52, 1 out of 26. In this problem, we have a contingency table. It says in a geographic region, newspapers are classified as being published daily morning, daily evening, and weekly. Some have a comics section and some do not. So we have our table here that represents the outcomes. Whenever we're given a contingency table, we should always add up each column to get the total and each row. The overall total is 15. There's 15 newspapers. So part A says the newspaper is an evening publication and does not have comics. Remember, and is the overlap, so it's evening and it doesn't have comics. That's 4 out of 15. The newspaper is a daily morning publication or has comics. So the morning publication, there's 5. The number that have comics is 6, so 5 plus 6 is 11, but we're double counting these two. So 11 minus 2 is 9. 9 out of 15 reduces to 3/5. Part C says the newspaper is published weekly or does not have comics. So weekly is 3. No comics is 9. 3 plus 9 is 12. But we're double counting these two. So 12 minus 2 is 10. 10 out of 15 reduces to 2/3. Number 8, we have another contingency table problem. We're given 80 students in a school cafeteria. We're asked if they favored a ban on smoking in the cafeteria. The results are as follows. Once again, we find the total of each column, total of each row. The grand total overall is 80. For part A, it says the following. Given that the student is a freshman, this is a conditional probability. He or she opposes the ban. So when it says given that the student is a freshman, we only focus on the freshmen. We do not include the sophomores in this analysis. So there's 50 freshmen. Of those 50 freshmen, 27 oppose the ban. So 27 out of 50. Part B, given that the student favors the ban, so we're focusing on those who favor the ban, the student is a sophomore. There's 23 sophomores out of 38 who favor the ban. And then finally for part C, it says the student has no opinion and is a sophomore. This is not a conditional probability. This is a regular probability, so it's going to be out of the total. So no opinion and is a sophomore. That's going to be 2 out of 80, and that reduces to 1 out of 40. So number 9 says the following. At a teacher's conference, there were 4 English teachers, 3 math teachers, and 5 science teachers. If, should say, 3 teachers are selected at random to be in a committee, find the probability that at least one is a science teacher. Well, whenever we see the phrase at least one, we're thinking it's the probability of 1 minus none are science teachers. So if we choose 3 teachers and we want none to be a science teacher, the total amount of teachers is 12. But we want non-science teachers, so that's the 4 English and the 3 math. So for the first selection, it's going to be 7 out of 12. That person selected. We can't reselect that teacher. So the next selection, there's going to be 6 non-science teachers out of 11. And then times 5 non-science teachers out of 10. We multiply this out to get 7 out of 44. Subtract. So the chance that there is at least one science teacher is 37 out of 44. This problem can also be done using combinations. So for our problem here, we have 1 minus. Instead of using the multiplication rule, we can say, well, we have 12 teachers, we're choosing 3, and we have 7 non-science teachers, we're choosing 3. Performing the calculation, 7C3 is 35, 12C3 is 220. This reduces to 7 out of 44. Subtract to get the same answer, 37 out of 44. So you pick whichever method works best for you. Number 10, it says, if there are 4 cans of cola, 3 cans of lemonade, and 5 cans of iced tea in a cooler, how many orders is it possible to consume these drinks? So here we have identical cans, meaning that the cans all look the same. So we're using permutations with repeating items. So first we count the total number of items, 12. So the numerator is 12 factorial. We count the number of times the cola repeats, 4 factorial, times the number of times the lemonade repeats, 3 factorial, times the number of times the 5 repeats, 5 factorial. Compute this value, type this in your calculator to get in the denominator 17,280, and then divide that into 12 factorial. The answer is 27,720. Number 11, to play the Super Lotto Plus, a player must select 5 numbers from 1 to 47 and 1 number from 1 to 27. Keep in mind, the word select, that's our clue to let us know we're working with combinations. How many possible Super Lotto combinations are possible? Well, we have 47 numbers. We're choosing 5 times 27 numbers, we're choosing 1. That's 1,533,939 times 27, which gives us a total of 41,416,353. Number 12 says, a hand of 3 cards is dealt from a well-shuffled deck. What's the probability that the hand contains the following? All are aces. Here I'm using the combination method. You could also use the multiplication method if you choose so. Well, all are aces. Remember, there's 52 cards. We're choosing 3. That's our denominator. There's 4 aces, and we're choosing 3. That's the numerator. 4 out of 22,100. And I just convert this to a decimal, 0.00018. For B, it's saying none are aces. Well, all the cards that are not aces, remember there's 52 cards, there's 4 aces. 52 minus 4 is 48 cards that are not aces. And we choose 3. That's our numerator. The denominator is still 52, choose 3. So we perform our calculation, 17,296 divided by 22,100. That's going to produce 0.783. And then finally, at least 1 is an ace. Well, whenever we encounter the phrase at least 1, it's 1 minus none. And we already calculated that probability in part B, so it's 1 minus 0.783, which is 0.217. Number 13 says the following. If there is a 25% chance of receiving a ticket for cruising on a Saturday night, find the following probabilities for 3 random drivers that are cruising. All 3 receive tickets. In this case, we're dealing with independent events. We have a small sample taken from a large population. So the chance of getting a ticket is 0.25. We raise it to the 3rd power because we're choosing 3 random drivers. The answer is 0.0156. Now it's asking that none of them receive tickets. Well, remember, we have 100% of drivers on the road, 25% receive tickets. 100% minus 25% is 75% do not receive tickets. So we take 0.75, raise that to the third power to get 0.422. And then part C is saying at least one receives a ticket. Remember, when we see the phrase at least one, it's one minus none, and we calculated none in part B. So 1 minus 0.422 is 0.578. And that concludes the video for the review. Thanks for watching.